Hello class, I had some questions concerning entering formulas into the calculator, and so I thought I'd go over some examples of just entering some of the formulas into the calculator so that we can actually evaluate and solve some of these problems in our homework. So before I start, I just wanted to show you that over here on this right hand side I have all the formulas that we could possibly be using for homework or even for the exam coming up. And on the left hand side I've got our calculator. I did want to start off with something simple just to get us warmed up, and so I'll go ahead and write something really simple on here. And let's say I have 3 plus 4 all over 7, and making sure that we can enter this into the calculator. Of course, this is going to be 1. If we look at the numerator here, we know that this is 3 plus 4, which is 7, divided by 7 is 1. So I'm going to go over to the calculator over here, and here's an example of doing this incorrectly. 3 plus 4 divided by 7. If I hit enter, it's going to give me 3.57, etc., and that's definitely not the number 1. So if you notice, what I did wrong is the calculator believes I'm taking the number 3 and then adding to the number 3 4/7. But the expression that I've got written here is 3 plus 4, that operation must occur first, and then you divide by 7. When you have a fraction bar, it implies that the numerator is protected by parentheses and the denominator is protected by parentheses. Now, I wouldn't necessarily have to protect the denominator because it only has one number and there's no operations going on. But in general, if there's either more than one number in either the numerator or denominator, or more than one operation, you must protect the individual numerator and denominator with parentheses. So I'll go ahead and do this again. So noting that 3 plus 4 is an operation in the numerator, I need to protect that with parentheses 3 plus 4, close parentheses, and then divided by 7. Now I know that this is going to return the number 1. So much of the difficulty, if I zoom in here on of these formulas, really isn't that we don't know what numbers to put in what locations. It literally is just trying to figure out how to enter this into our calculator. Alright, so I'll put this back over to the side, and these ones seem fairly easy to do. We're going to jump right into something more difficult here. So this one is compound interest formula. So the total amount is equal to the principal times 1 plus the interest rate over the number of times you compound to the power of nt. And let's say that I'll get my pencil out here. Let's see, I've got A is equal to, let's say, $10,000 times 1 plus the interest rate's 4%, let's say. So there's the decimal version of 4%. And let's say it's compounded every month, so n would be 12. And let's say we do this for 10 years, so n is 12, and then t is 10 years, so times 10. So I want to get this entire expression. That should be 10,000. That looks really horrible, so my apologies. 10,000 times parentheses 1 plus 0.04 divided by 12 to the power of 12 times 10. So my calculator, I can immediately start with just 10,000. So there's 10,000, and unfortunately does not put commas there, but that is 10,000. And then notice I have a parentheses here, just like I do in the formula. And so I'm going to enter the parentheses, and then 1 plus the interest rate's 0.04 divided by 12, another parentheses, and something to note, there should be an even number of parentheses. So I'm not going to have 3 parentheses, 7 parentheses. There's always going to be 2, 4, 6, 8, etc. Then the exponent button is right above the divide by symbol, and I need 12 times 10. Now you could put 120 if you in fact know that 12 times 10 is 120, but let's just say I do not know. 12 times 10. Okay. Now in the newer calculators, it keeps the exponent raised and high, but in the older ones you might have to put a caret, but then in parentheses put 12 times 10. I'll go ahead and hit enter here. So the total amount after 10 years at 4% compounded monthly is $14,908.33 if I round. Now I'm going to go ahead and let's just say that we have an older calculator. It does not do this fancy putting the exponent entirely raised. So I'll go ahead and do this again. 10,000 parentheses 1 plus 0.04 divided by 12. Okay, and now caret means exponent, and I'm gonna put parentheses just in case, 12 times 10, and then close parentheses. Now that ensures that my calculator knows that that function of 12 times 10 is built into the parentheses. And then I can move this over and hit enter, get the same result. Okay, so let's do this one here, and it's a little bit more difficult than the one I just did. I'm gonna enlarge this here. Okay, and I'll write over here the example that we're going to do here. We're going to do, let's say that the future amount that I want to get to is $20,000, and I want to get to $20,000 where I know that the interest rate is, let's say, 10%, and it's compounded monthly, and we're going to do this for, let's say, 10 years. Well, let's pick something, 20 years. So I've got 12 is n and 20 is the number of years. Alright, so now this is where we have to be especially careful because the denominator has this complicated expression. So when we write divide by in our calculator, we're going to put a large set of parentheses to protect the denominator. So if you wanted to, you could be extra paranoid and put another set. Square brackets is just another set of parentheses. Just doing that so to emphasize that the entire denominator is in parentheses. So I've got this expression, and let's say that I want to put this into the calculator. Move this back over, and oops, let me see if I can center that without causing too much of a stir there. There we go. So I've got 20,000 as the first item. This would be a formula that you would use if you wanted to save to a future amount. So this is how much do you put in now, P, to get 20,000 in 20 years. So 20,000, that's the numerator. Divide by parentheses, and now I'm going to enter this expression, another parenthesis, so it's nested. 1 plus 10% is the interest rate, divided by 12, because that's how many times it's compounded per year. Close parentheses, so now I've got 1 plus 0.10 divided by 12. Here's the parentheses, then caret, that gives me the exponent, and I'm going to assume that we don't have this fancy calculator that I have, and so I'm going to protect the exponent, 12 times 20, because some of us have older calculators. Okay, and then the last thing, you could count, but I need another parenthesis on the right hand side, and the calculator, at least this one, makes it a little bit larger. And now if we hit enter, this is how much I had to put in now to get $20,000 in 20 years, and I had to put aside $2,729.23. To be safe, you'd make 24 cents because I've got this extra piece there, and that would guarantee you that you'd have $20,000 at the end of 20 years. So you have to be patient, and you know, 10% is pretty aggressive, so you must be putting this into some sort of growth, high growth potential. Maybe it's a stock or something. It definitely wouldn't be a bond. Alright, so we've got that formula. So we've covered this formula here, the total amount if you have a certain amount that you're going to invest, or a principal, and this is the future amount formula. Okay, I'm going to skip the yield one because that's not a very complicated one to enter in the calculator. I'm going to go to this formula here, the total amount, if you have a certain payment that you do regularly, and here same thing. Over here this is for an annuity, and I'll do the first one. So I'm going to use an eraser here and erase what I have here, just so I can use the same space. Okay, I'll get back to my red pen, and let's say that the total amount that I want to have is, let's say we'll keep it 10,000, and I have bracket 1 plus let's say 5%, and let's make this monthly, and let's do this for 10 years, so it's going to be 12 times 10, and there's the minus 1, there's the closed bracket, all over, and I said the interest rate was 5%, and it's compounded monthly. Alright, so I'm writing on a tablet, so my handwriting's bad already, so writing on a tablet even exaggerates that effect, but hope we can see that, and I want to enter that into the calculator. Notice that in the denominator I've got a complicated expression, and the numerator I've got a really complicated expression, so the numerator is going to be protected by parentheses, and so is the denominator. So for the numerator I'll start off with parentheses, and then 10,000, and then I've got a bracket, just another parentheses, so I'm literally just copying these parentheses here. 1 plus 0.05 divided by 12, close parentheses, to the power of, and I want 12 times 10. You know what, I know that 12 times 10 is 120, so where I can I'm just going to write, keep it simple. Okay, then move to the right and subtract 1, and then parentheses over here on the right, but I want to pair this up. There's one parenthesis I had at the very beginning on the left hand side of 10,000, so I need one more, and again you could count. There's 1, 2, 3, 4, 5, 6. Okay, now divide by, that's the fraction bar, parentheses, 0.05 divided by 12, and close parentheses. So this is such a complicated expression to enter in the calculator, you can't even see the full keystrokes in the calculator screen. Hitting enter, and the total amount after, what did I say this was going to be 10 years is, I wish this had commas, $1,552,822.79. Okay, so somehow if you were able to put in said $10,000, can't read my own handwriting, and do this repeatedly over and over. Which one did I do again? Right here. Yeah. Okay. So that's the total amount, and let's see. I'm going to go to the next formula here. It's the future amount. What do you need to put in here for P to get this future amount A? Okay, and so let's see here. I'm going to clear this screen so it's a little bit, and I kind of want to keep this space here, so I'm going to erase that again. That's pretty bad handwriting there, but I'm going to erase it. Okay, go back to drawing again, and so we're going to use this one here, and let's say how much do I need to put in. Let's keep n to be 12. We'll do this monthly. How much do I need to put in every single month to get a total of, let's just make it something nice, P equals, let's say we want to get 20,000. I'm kind of repeating myself here. And the interest rate is, let's say, 8%. And every month, at the end of the month, I put in a certain fixed amount, P, and I want to get $20,000 at the end of, let's say, we'll do 10 years. So I've got a bracket here, 1 plus, I said 8%, compounded monthly, there's my 12, parenthesis 12, I said 10 years, and then minus 1, and then a bracket here. Alright, so this would be a situation in which A is what your goal is. My goal is 20,000. What do I need a single month, because we're doing this monthly, to eventually have an annuity that would get to 20,000. Here it's 8% growth rate. Alright, so I've got this complicated numerator, complicated denominator. I need to protect these things with parentheses. So I'll start off, parentheses, 20,000. I think that's 20,000. And I have parentheses 0.08 divided by 12, parentheses, and then divided by parentheses. So now I'm operating down here in the denominator, and then there's another parentheses, it's a bracket, and then a parentheses here. So, and maybe I should make this look a little bit better. It looks like another 1 there. There we go, parentheses. And then 1 plus, is it 8% divided by n, which is 12, parentheses, and then the exponent button, which is a caret, and then 12 times 10, I'll just pretend I forgot what that is. 12 times 10 minus 1, and parentheses. And what do I need to put in every single month so that in 10 years I have $20,000? And it is, let's see here, oops, I must have forgot something here in my, so I can't put in a 4/10 of a penny. Let's see here. Let's see here. Okay. Let's see, when I go up to my entry here, and let's go second entry so I can actually edit it. And then let's see here, try this one more time. Second entry. Where'd my cursor go? Should be able to move it. Maybe I'm too far to the right. Okay. Second entry. Okay, how about insert? Second insert. Why can't I? Okay, let me clear this. And notice I forgot to put -1 there, so I'm going to clear this. Okay, maybe I have to start over. I'm having a little bit of difficulties here just trying to get my virtual calculator to get my cursor up there. There's my cursor. Okay. Second entry. Okay. So now notice there's the 1 plus 0.04 divided by 12. Oops, that's, oh, I had the wrong, let's see here, oh, this is a different problem there. I totally started from scratch here and deleted what I already had on there. I guess I got over confident there in what entry I wanted to enter. I'm just going to enter this again. So sorry about that. 20,000 parentheses 0.08 divided by 12 parentheses divided by, then parentheses 1 plus 0.08 divided by 12, parentheses, caret, and I'll even do 12 times 10, even though I know it's 120, and then minus 1. I didn't subtract 1 there. And then I've got parentheses and hitting enter. So one little, I forget to subtract a digit in the denominator, spelled catastrophe, and I knew it as soon as I did that. I forgot to put the minus 1. So here's what I would do: is $109, and to be sure, 33 cents is what you would put in every single month, so that at the end of 10 years you'd have $20,000. So I'm kind of glad that I actually made that mistake, so that you could see that, you know, simply messing up one of these values, either in the numerator or denominator, can have drastic consequences as far as, you know, what your answer is. So there wasn't a data entry with parentheses that made the mistake. It was, you know, the data entry I forgot to actually input a number. All right, so I'm going to erase that. And so now we're going to do one of these last formulas here. And again, I apologize for that. I just forgot to subtract 1 in the denominator, and that cost me quite a bit. Okay, go back to here. And so this would be trying to compute what my payments are to pay off, let's say, a mortgage. Okay, let's see here. I could write this larger. Can I zoom in on that? It's pretty small. Oh yeah, here's the zoom in. Let's search. Try to make this larger. Well, okay, I'm not going to try to on the fly make this larger for you to see, but this would be the payment. I need to know what the principal was. So maybe after I had my down payment in my house, I owed $180,000, or maybe on the down payment on a car was $4,000, and after that I still owed $16,000. So this capital P here is how much is the original loan amount. So we'll come up with something, let's say that we're trying to figure out the payment that we have to make every single month, and let's say that, let's do a house. Let's say I've got a $200,000 house, and I come up with $40,000 for down payment, so that still need to come up with $160,000. That's the face value of the loan. So this would be P in the formula. So by the way, I'm doing this one right here. And let's say the interest rate, I really don't know, it's pretty darn low right now, especially with the crisis we're having right now. Let's say our interest rate is, well, we got really good credit, 2%. So I'll put 2% here, and it's every single month. So N is 12, and copying the formula down here, 1 minus parentheses 1 plus 0.02, sorry about that, divided by 12, parentheses, now this is a negative symbol here, a minus, and then 12, and let's say that we have a 15-year mortgage, so this is times 15. Alright, and I've got a closed bracket. Okay, so here this is a negative symbol right here, and that's the negative symbol. So this is every single month. What's my payment going to be? And here the time is 15 years. So this is supposed to be a 1 and a 5 for 15. So I've got a complicated numerator, a complicated denominator, and let's see. Let's go ahead and enter this in. So parentheses, here comes the numerator. 160,000 is the amount that I had to pay for the mortgage. Okay, that looks good. And then I've got 2% interest rate on the loan, divided by 12, parentheses, parentheses. Now the fraction bar is divided by, again, a bracket's just a fancy parentheses. 1 minus parentheses 1 plus 0.02 divided by 12, parentheses, caret. So that's the exponent. Since I've got a kind of a complicated expression going on in the exponent, I'm going to be extra careful and put parentheses up here in the exponent. Now this is a negative symbol, not a subtraction, so the negative button's on the lower right hand corner. Do not use the subtraction key on the calculator. This is the negative button. So negative, and then 12, because that's n is 12, and then times 15 years. And then close parentheses. So minus 12 times 15, that's occurring right here in the exponent. Now what I did last time was I forgot to do the extra piece here, but I'm not going to forget that. In fact, it was done early, so I'm not going to forget that. So I'm going to move down, and I have one more set of parentheses, so close bracket. Alright, hitting enter. Let's see how much I had to pay every single month. And $1,029.61 every single month, and I get to pay off this $160,000 house at the end of 15 years. So that problem introduces yet another potential problem that you could have on homework, and it also has that negative symbol. You do not want to put a subtraction symbol. So I think I've got almost all the complicated formulas, and I think that should help us out in entering these financial formulas into our calculator.